Hey, manufacturing world, welcome to another episode of Shop Matters, sponsored by Okuma America. The podcast is designed to talk about all things manufacturing related. Today, joining me in the studio, I've got Mike Hampton from Okuma America and Andy Henderson from Praemo. Welcome, guys.
Yeah, thanks for having me.
Thanks a lot. It's happy to be here.
All right, so let's do a quick introduction. Mike, tell us a little bit about yourself and what do you do?
Yeah, absolutely. So I've been in manufacturing since 2010. I was actually on the customer-facing side, worked with a number of brands of machine tools, being lathes and mills of some of our competitors. And since 2018, I've been with Okuma America, and I'm strictly focused on business development for the aftermarket parts and service side. So that's what I do on a day-to-day basis. And the topics we're talking about today, I have an extreme passion for. So.
2018. It seems like you've been with us like 6 months.
I know. Time flies when you're having fun, Wade. So.
Hey, that's the way to say it. Jim King might listen to this. So
perfect.
Andy, tell us a little bit about you. What do you do?
Sure. I'm Andy Henderson. I'm the CTO for a company called Praemo. And Praemo does advanced data analytics. We utilize technologies like AI to help us make better use of data faster. And we focus primarily in the industrial operations space. My background, I'm an engineer, specifically a PhD in automotive engineering. My research while working on my PhD was an updated cutting force model when milling nickel-based superalloys. So
wow.
Somebody at Lockheed said, yeah, those are the really angry metals. And so, yeah, they are, because they tend to, in most forms of machining, we tend to talk about things in terms of like parts per tool.
Right.
With nickel-based superalloys, we talk about things in terms of tools per part.
Mm-hmm. Yep, tools per part or minutes per tool.
Yeah. And so my research a number of years ago was around understanding understanding cutting forces for the purposes of trying to understand tool wear and optimizing consumable cost and cycle times when machining those alloys. And then that was really interesting to GE Power, which is where I went after that. I
was just going to ask, how did you make a transition from automotive engineering and studying nickel-based alloy machining to AI-type conversations?
My entire career has, in some way or another, revolved around data acquisition and analysis. So my first role out of my undergrad. So I took a non-traditional path to my PhD. I finished a bachelor's in mechanical engineering, and I went to work for Caterpillar doing diesel engine testing and development. And so there it was all around designing tests or working with pre-production diesel engines in order to put them through their paces, do validation testing, and identify failures that may occur, root causes, and then working with the design teams to try and adjust to the design of that product to mitigate those issues before they actually release to the customer. So it was a lot of speccing sensors, designing tests, putting sensors on engines, data acquisition of that data, getting it into something that we could then go take and do further analysis on, in order to link it back to, like I said, root causes or other failure modes that occur. And then going into the PhD, a lot of what I was doing during my research was designing tests, acquiring data for the purposes of training, of building a model to understand what was happening in the midst of the machining process. And then at GE, it was all around improving GE's internal manufacturing operations. So working with folks on the shop floor to understand, how are you doing things today, and are there other technologies that may exist? Maybe it's a new coating on a cutting tool that extends the cutting tool's life that you can make use of in this operation, in this machining operation, to lengthen tool life or run the process faster to cut cycle times down. And so a lot of that was gathering data about what was being done today so that we could establish those baselines and know if any changes that we made actually did make an improvement to the process. And so it was still a lot of data acquisition and analysis, and but it's very manual. And so when the AI piece was around, I was doing some online courses about AI, and I'm thinking, hey, these these algorithms are built to try and make sense out of that data and have the machine learn those relationships between,
and kind of meld the two together.
Yeah, and so it should be able to help us, because my manager at GE would often say, hey, another great set of projects, way to go. But how do we take this team of, I forget the numbers, we were in the I think we were in the teens as far as the number of people supporting internal operations, and so there couldn't be an Andy at every single facility that GE had around the world. So how do we take what I was doing and scale it? And so it was a lot of, well, we can definitely automate that data acquisition, which is where I had already known Okuma for a long time because of my research. Even I was using an Okuma in my research, but it was through that of how do we get to the data and pull it in an automated way was where I got even more heavily engaged with you guys, because the OSP control really makes that easy, right? Yeah, there are various things that you guys have done over the years that makes it easy to get a lot of really valuable data off the machine itself without having to go spec out and put new sensors on and put expensive data acquisition systems in place.
One of our control engineers used to say that we had over 9,000 sets of data points that you've got access to through the OSP control. Yeah. Most people can't scratch the surface on that, but there's so much underutilized information there. Yeah,
and so that's AI, right? Or that's where AI comes in, is how do you make use of stuff like that? Because the traditional approaches are going to be, you make some graphs that show those 10 of those 9,000 points trending over time, and somebody sits while they're sipping coffee and that doesn't look quite right. Let me go figure out what's happening there. But that's where things we talk a lot about trend detection and anomalies, and that's a foundation of what you start from, is you're looking at that data, looking for trends and anomalies, because that's what the person sipping their coffee is doing too. They're looking, saying, hey, that line that's been going in the wrong direction, or that was a weird spike in that data item. I got to go figure out what that is. So but he can't do it on all 9,000 data items for one machine, right? Because he's got 20 machines. Maybe, as in the case of GE, one facility had 500 different assets that we were trying to capture data from. So multiply that by 9,000, and it's an unwieldy data set. So like, you apply these tools that are doing some aspect of what that person's doing. I keep saying guy, could be a gal, right?
Yeah.
What that person's doing as they're reviewing the data. So letting the analytics engine run on that data and bring those out so that those people can be doing their normal jobs, be out on the floor trying to execute on projects, and then the engine says, hey, there's something weird in this related to these particular data streams on this particular asset. Maybe you want to go take a look.
Yeah, very cool. So, Mike, you come from a background of plant operation and production. Tell me a little bit about the importance of predictive maintenance and preventative maintenance. What's the difference between those two?
Yeah, absolutely. I think the ultimate goal, whether you're looking at any manufacturing facility, is to be focused on uptime. And both of these have to do with uptime, but the real difference between the two is preventive maintenance is performing maintenance that is scheduled, controlled, and measured to restrict the possibility of having unforeseen downtime. So it's saying, I'm going to bring this machine down on X date. I'm going to change these components. I'm going to focus on these areas and then bring it back up. So the machine is running when I want it to run. And predictive maintenance is slightly different, but it's using data to predict when items are getting near the point of failure. So whether that's focusing on vibration of a spindle or different wear items or the wear of a ball screw, it's using data to say this component is getting close to its failure point. Let's go ahead and schedule the machine to come down. Let's replace that component so in the future the machine will stay up. So when our maintenance crew isn't here in the middle of the night, it's not going to fail. So both of these preventive and predictive maintenance are both going to help the machine run. And we really practice preventive maintenance in everyday life. And I like to compare it to household items. So why would you perform preventive maintenance? And there's a lot of reasons. But first and foremost, machine tools are very expensive. And you want to protect your asset. And a good comparison is your car. I mean, cars are very expensive too. Most individuals have them. Why do you change the oil in your car? You change the oil in your car so the motor continues to run. If you don't change the oil, you're going to lock up the piston and the block. You're going to have a huge expense to overcome, and it's going to be extremely frustrating. So you schedule your maintenance. That's going to protect your investment. Another example is, let's just say your HVAC system in your house. Everybody changes the filters to their air handling system every 3 months. Why do you do that? You do that because you want your system to perform as good as it can, and it's also going to let the air flow through at the proper rate, making that air handler last longer. So another example I like to point to is a fire alarm in your house. So individuals change the batteries when it starts to beep. You don't do this after it goes completely dead. You do this when it's beeping because you know it's getting close to the point where it needs to be changed. Why do you do this? Because it's a safety factor. So in everyday life, people practice preventive maintenance, and it doesn't change with a machine tool. You need to apply it to a machine tool as well, for all of those reasons.
Okay. So the efficiency side of it, that's such an important factor from manufacturing. For people to be the most profitable and most competitive they can be in the marketplace, their process has to be as efficient as possible. So the maintenance aspect of it tends to be one that is kind of low-hanging fruit. I think a lot of people overlook it or they put it off. I'm on a school board, and we're dealing with maintenance on some school buildings right now. And some of the facilities that we're dealing with, what we're dealing with is the fact that because of budget restraints and just different issues, well, let's forego it. Let's push that off another 2 years, and then let's reevaluate the roof. Well, okay, let's push it off another 2 years, and then we'll reevaluate it. Meanwhile, that roof's still leaking. There's still issues going on. That's creating other processes down the road that we're having to deal with from a maintenance standpoint. So at some point, a guy used to tell me, pay me now or pay me later, right? At some point, you've got to take care of it. So what tools do you guys have in place that gives tools to customers to be able to handle preventative maintenance in a smooth transition?
Yeah, absolutely. So one of the things that we've launched recently is the CARE Preventive Maintenance Kit. And what CARE stands for, you might know or you might not, but it's an acronym. It stands for Constantly Available Resource Experts, and that's been around since IMTS 1993. So
I don't know if that's a Japanese thing or Okuma in general. We've got acronyms for acronyms, don't we?
We do, but this acronym, it's a good one. And not only do we care, but we want to express that we are experts, and no matter what situation arises, whether it's a field service issue, an application engineering, a service parts break fix issue, a mechanical or electrical exchange issue, whatever the issue is in the field, we want to supply a solution. And that's what Okuma Care is, and that's why we launched the Okuma Care Preventive Maintenance Kit. And what this kit is it comes with all the necessary components to do a full preventive maintenance, a robust PM on your machine tool, and it's one box. So you get one box. You have, if it's a lathe, it's going to come with all the necessary filters, the way cover wipers, the saddle wipers, all of the necessary wipers that need changing along with other components. And if it's a machine tool, it's going to have all of the filters, the O-rings, the springs needed for the through pin. And the through pin is going to come in the kit as well, because ultimately that's going to protect the heartbeat of your machine, which is the spindle. So this kit is delivered to our customers. They open up the box, they can perform the PM. It's going to protect their mechanical, electrical, their lubrication, their coolant systems. At that point in time, you'll do a full machine inspection. Just like if you were to take your automobile to the dealership, they're going to change the oil filter, they're going to change the oil, they're going to change the air filter, they're going to do a full inspection, and they're going to say, hey, you might need new wiper blades. Our service technicians are going to do the exact same thing. So when that car pulls out of the dealership, it's in like new condition, and so will your machine tool. It's the exact same thing.
How's the preventative maintenance scheduled? Is there a list of time frames for each machine that is predetermined, or is that something based on the customer utilization?
Yeah, it's based off of utilization, but there's obviously recommendations that come in your operation maintenance manual that's provided with the machine. And it's also tracked in the control. So we have great functionality in our new controls that know exactly how many hours have been run. And we can set periodical maintenance interval suggestions, and it'll actually set an alarm on the control telling you when you should perform your PM.
Okay. So if a customer has a unique manufacturing process and the preventative maintenance that he's wanting to do, maybe there's a few items beyond what comes in the predetermined kit, is that something he can incorporate and work into his personal preventative care kit or preventative care process?
Yeah, absolutely. You can tailor it in any form or fashion that you want to. So you have the ability to go into Echo Suite. On the Okuma control, there is a maintenance monitor piece of software. You can go through the whole list of pre-suggested periodical maintenance, and you can add to that.
Okay. So, Andy, how does the anomalies and the AI side, how can that tie in from a maintenance standpoint in determining the health of the machine and the longevity of the process that you're working on?
Yeah, I wanted to take I'll come to the question, but I wanted to talk about, like, there's always a question of data's great, what do we do with it? And one of the things that I've seen that was, and you touched on it, right? The notion of, or both of you guys touched on it, right? There's the calendar base where you can say every 3 months I've got to do something, or every 6 months I've got to do something. Well, a lot of machines are tracking hours, and so you can be more, I don't know, deterministic is the right word, but you can say, now instead of just going and doing maintenance every 3 months, let's do it based off of the number of hours. And so a lot of people, when they're thinking about trying to get at data for some reason, they say, well, AI is the big buzzword. That's the new thing that we're going to go after. Well, there's a lot of, and I think that should be part of the strategy. In the meantime, while you're working towards that strategy, going and doing things like collecting all of those hours and using that to trigger maintenance work orders in a CMMS system can be a very what's the word I'm looking, a value. It can add a lot of value to a maintenance program, just having that. And I've seen it, right? I've seen where what people are doing is they're looking, they at first they have a calendar of all the assets and when they need to go touch them, and then they go and they find out, hey, this particular asset actually hasn't done anything in the last 3 months, but we're going to do the PM anyway because that's what the calendar says we should do. And then they move to a system where there's a person walking around with a clipboard, and they're checking all the controls, saying, well, what's the runtime hours on that? And they write it down and they use that to make their decisions. And then you can say, well, let's string a line, or let's figure out how to get that data off of that control and store it somewhere centrally. And what that does, right, is now it opens up all those 9,000 data points that we can start churning on and processing. It makes them available to us. So you can use that as a value proposition to expand into this bigger opportunity that you may have by applying advanced analytics on top of it. But your question specifically was how does AI or how does an advanced analytics engine help in the maintenance piece? How does it help in the preventative maintenance side of things? And a simple example is like that I was talking about trending, right? Trend and pattern detection. So if you're gonna put an accelerometer on the bearing of or around on a motor casing near where the bearings are on the you're going to have to monitor that in some way. And what are you looking for? You're looking for a trend in some direction or another, and that trend is what's going to tell you is what you're going to then base your understanding of the health of that bearing off of. So what am I talking about? So like the accelerometer is on the motor casing. You're monitoring the vibration of that motor around the bearing, and so you're going to be probably in that case you're going to be doing something called like a Fourier transform. You're going to be looking at the frequency content, and you know that the bearing is supposed to have a vibration signature at some frequency, and then over time you're going to see some other frequencies start to creep up, and it's tracking the trend of those other frequencies showing up on that Fourier transform. It's the power spectrum. When they start to show up, then you can trace how much like the magnitude of it. And what you would want to know is, okay, what's the magnitude of that when this thing is reaching the end of its life, when it needs to be replaced. And so an AI engine can take that data and learn those patterns and learn when in the past action has been taken to replace that thing, or maybe it's something like you're talking about a moment ago with lubricants, changing the lubricants out, because you see the same exact thing. There's going to be a trend to some point. A lubricant is going to be changed, the filters are going to be changed, there's going to be a reset, and it's going to keep on trending. We see this in tool life, right? It's well known that the power, in most cases, power increases as a tool wears out, and you see the same exact pattern there. So the AI engine is looking for those patterns in the data, looking for when those resets happen, and it's saying, I know based on the trajectory of this trend and or I've learned based on the trajectory of this trend and when resets have happened in the past, when action needs to be taken. And so it can be that thing that says, okay, at this point, let's trigger an alarm, let's make a notification that says action should be taken to go replace that cutting tool, should be taken to go change that filter, should be whatever, right? And so the reason it all makes sense. And people say, well, we do that anyway, right? We don't. What do we need an AI system to tell us that for? Well, the AI system is taking into account all of the other variables as well, because in the case of a cutting tool, it might process 10 different products, and each one of those has a slightly different impact on the life of that cutting tool. And so it's not always a set threshold, a single alarm, but it's a combination of a whole bunch of factors that go into that component's life. And so the AI tool learns to understand those and incorporate those into its projections as well. I feel like I may have gone off the deep end there a bit. Hopefully I brought it back. Did I answer your question?
Yeah, all interesting stuff. It's neat to see how the technology changes and can be incorporated to a manufacturing process to make you more efficient, make you leaner on how you attack parts and the type of work that you're doing. Again, I always say the more efficient you can be, the more profitable you can be, or the more productive you can be. So what are some working examples that you've seen from a machine tool standpoint where you've utilized Praemo and changed the way a manufacturing process is?
We have a customer that we like to talk about where, and it was simple. What we were doing, relatively simple, or it's simple from a high level view, and it was learning what typical cycle times of the machine were. And it's not, we often do this, right? Where software vendor comes in, they say, and somebody in operations says, well, just tell me when my machine is sitting idle. That's what I really want to know, when it's sitting idle for too long. The software vendor says, okay, well, what does idle for too long mean? I don't know, 10 minutes. If it sits longer than 10 minutes, let me know. Okay, we can do that. We set an alarm, machine sits idle for longer than 10 minutes, it sends a text message. Great. Well, then they get flooded with text messages because 10 minutes was too conservative on one side, and then something escapes and they don't get notified about it because it was too long on the other side, right? So some parts of their operation, 10 minutes is fair, right? It takes 10 minutes to do a change. In some other parts, if it takes 10 minutes, it's disastrous,
right?
And so what the engine learns in that case, right, is it learns to recognize the nuance between those two and set limits accordingly, all on its own, without having to have the person say, I don't know, 10 minutes. And so providing this to one of our customers, they were getting notifications about cycle times that were too long, and this launches an investigation. It says, okay, well, that's odd. The cycle times are longer than expected. We wouldn't have necessarily known it otherwise because it would have gotten hidden in the noise of everything else. But cycle times are too long. Let's go figure it out. And they learned that it launches this investigation that raises a few things. One, we should adjust the size of our Kanbans. Like we need to tweak how much is sitting there ready to go, or that's available at any point for the machine to consume and use. Mm-hmm. The other thing is, there was a one of those changes happened over the duration of a month. Well, actually during the duration of that month is when we had different operators flowing through. So it's not necessarily a skill set thing, but maybe we just need to keep people cycling around to keep them refreshed in different parts of the operation so that we can keep parts moving effectively. Mm-hmm. So does that answer your question? Is that what you were looking for?
Yeah, I was really looking for what are some customer examples where you guys have installed Praemo, you're doing some AI analysis, and what does that look like for a typical manufacturer that has never utilized it? So I know you've got some installs on the East Coast here on some Okuma equipment. What's kind of the low-hanging fruit that you see that customers can realize a ROI on that investment and incorporating that into their production system?
So it's things like what I was just talking about. That's probably the one of the easier ways to do it, right? To get those notifications, because it doesn't tell you exactly what the problem is immediately, but it tells you the area to go look to say, that's weird. I need to go address it. And when you do address it, so that particular customer takes they support MRO businesses, so they get phone calls. I need something in 24 hours, and if they can't deliver in 24 hours, they lose that sale. So like they're really focused on taking the total the time from order comes in to the time it leaves a shipping dock down from, I think it was like 5 to 7 days down to 24 to 48 hours. And by addressing those things like I was describing, it enables that. Now I can't say that Praemo solved that entire problem, but it was a contributor, right? It was part of a holistic approach that really helps you drive that overall order comes in, leaves a shipping dock. It helps you condense that down. So that's an example. Mm-hmm. And from the customer standpoint, our philosophy is it should be super easy, right? Mm-hmm. So what we, when we engage with customers, it's all about give us a data set, and don't worry about trying to clean it up. Don't worry about trying to harmonize the data, have everything make sense. Just we want it as raw as possible. In fact, lots of times when people try to clean up the data for us, mm-hmm. it ends up adding some amount of human bias on top of it that we have to then unweave, right? We have to go back and figure out what they were doing. So raw as possible. Therefore, don't spend as little time as possible just getting the data out and getting it over to us. We've built Razer to just churn and process and find these interesting points in the data and the time span of the data that we can then go back and say, here's something that Razer is identifying as being interesting. Is it truly useful to you in this case? Yes or no? If it's no, then we keep tuning and say ignore that. If it's yes, then keep tuning to say keep finding those things for sure. Now let's go find some other stuff that is useful.
Now that's something I realize I don't think we've touched on is what is Razer. So I've been talking about Praemo a lot, but Razer is your actual product that we would typically see on a machine tool, correct?
Yeah, Razer is our analytics engine.
Okay.
It is there's a bunch of we've got a bunch of data scientists and software application folks that are building that engine, and it would sit. You mentioned edge and cloud mm-hmm. at some point. It's all of our customers to date use Razer in the cloud.
Okay. Are there any connectivity concerns that you see from utilizing the cloud? I know a lot of your higher end aerospace shops, for an example, won't let some of their machines be connected to go out to the cloud. It's got to be internal. Do you guys run into situations like that?
Yeah, we there's that concern, which stems from security, and in fact, I have some experience from a prior life with ITAR, and a lot of it revolves around ITAR, or the U.S. government. What is ITAR? What's that acronym for? Everybody's got their own acronyms, but I forget. Right? It's making sure that foreign citizens don't have access to that data.
Right.
Is kind of what it boils down to. And so that's a thing that drives it. Another thing that people talk about is latency. So I've got this thing that I've got this high-speed accelerometer data. I want to be able to process it as fast as I can, sending it up to the cloud, letting something in the cloud process it and send results back down. That takes too long. But so there's two different reasons why somebody may ask us for an edge approach versus a cloud approach. Edge being closer to the floor, to the shop floor. Do we run into those? Yeah, we run into them, but so it's a lot about finding where value can be addressed today. So can we work in all of those situations and work around and figure out ways to provide value if security is a concern, if speed is a concern? Yes, we can, but do we need to start there right now? Is there something else that we can do where there's a lower barrier of entry that we don't have to solve all those problems up front? Yeah, and we can provide value based off of those too. So I guess the messaging would be, don't get hung up on those challenges. Let's go
explore it.
Let's go explore it, and let's go realize the value that's available to us today, and we can lay out the roadmap to be able to put all those pieces in. And so a lot of our opportunities to date have been in that, right, where we've been able to say, we can deal with security, but let's go. What about the stuff that's not ITAR controlled, or what about things that don't require high speed data transfer and analysis?
Okay, Mike, how does ConnectPlan tie into the predictive, preventative maintenance, understanding anomalies? As companies like Praemo are able to detect them, what would we do from a connective standpoint on the control?
Yeah, absolutely. So I'm just going to back up a couple steps. ConnectPlan may not be widely known to all. So what is ConnectPlan? And we started this conversation by talking about preventive and predictive maintenance. We talked about the care kits, which are the physical parts or the wear items, the components to perform a robust PM. Andy got into the data section, and then he was talking about walking around a manufacturing facility physically with a clipboard to collect data off each individual machine. So what is ConnectPlan? Well, ConnectPlan is a smart factory. It is a machine monitoring software that Okuma has produced. And what you can do is you can remotely see your whole factory in a visual layout. So you can open up this great visual layout that shows all of your machines. So you're physically looking at your facility, and you can be fishing at the Wando River in Charleston, and you know exactly what's going on inside your manufacturing facility. So you know every time that every machine is running, you know every time that it's not running, you know when a tool change is taking place, you know when a part is being unloaded or reloaded, you know the maintenance that has been performed on your machine, you know every alarm that has gone off. So it just gives you all of these different data points to help you increase utilization in your manufacturing facility, which is just a great tool.
Mm-hmm. It seems to me like there'd be a good harmony between ConnectPlan and then Praemo, from ConnectPlan giving you the big picture view of the health of your manufacturing process, what's taking place at any given time, and then when you needed to really deep dive and understand and find these anomalies. And as we talk about data, I always think about like the talk about the 787 and is it a terabyte, I think, of data that it pulls off every flight. But one of the engineers that we talked to said, while that's neat to talk about, we pull all this amount of data, we're only looking for a small set of data that we're actually going to make an executable plan off of. So I see these two pieces really tying in well together.
Well, Andy talked about wanting the raw data, and ConnectPlan, what it's doing is it's pulling these data points and sending it to a server, and we can remember up to 2 years of data. So with that said, we could export it, provide Praemo with the raw data from 2 years, and that's a great starting point.
Mm-hmm.
Yeah, and we love those, right? Because when we talk about what's our core competency, it's all about the analysis, and so we tend to look for platforms. I don't know if you guys want to use that word, but platforms like that do the data collection, putting it all in one place, because that's a single point that we go to, as opposed to try and create adapters for all the disparate systems that may exist on a shop floor. So we love to do those types of partnerships because we just don't consider the actual extraction, collection of data at the very edge to be part of our core competencies.
Mm-hmm. All right, very good. What have we missed? Any key topics that we wanted to hit that we didn't?
Well, I'll just say we mentioned ConnectPlan and how it's a machine monitoring software. And one thing I would just like to let everybody know is this can be used with non-Okuma machines as well. So we can still connect to a Mazak or a Mori or whatever type of machine it is and collect data off of that control, in addition to obviously all Okuma machines.
That's an important piece, because very few shops only have one brand of machine tool, right? Every place you go, there's multiple controls, multiple styles of machines, so that's a very important piece, and I would assume you're the same, Andy?
Oh yeah, for sure, and that's that's key to what I was saying a moment ago as well. That's why we like working with those types of platforms, is so we don't have to know about all those different nuances. And I kind of smirk, because I remember having some conversations with some Japanese counterparts a few years ago around having lots of different types of Okuma does some great things for making data available. Part of our challenge is that there's a lot of other machines out there too that we have to tap into, and there's value from looking at a particular asset, but then like that value is probably multiplied when you start looking at chains of assets and a whole facility of assets, and merging that data together to tell you a more holistic story is extremely valuable.
So Mike, somebody wants to learn more about Okuma care kits, anything like that. What's the best way to get in touch?
Yeah, absolutely. Contact your nearest distributor and/or go to Okuma.com. If you go to Okuma.com under the customer care tab on the website, you can see the navigational point that goes straight to Okuma care kits, or you can go under technology and machine monitoring, and that'll take you directly to the landing page for ConnectPlan, and you can actually fill out a call to action or a CTA requesting any additional information. It'll be sent to distribution and Okuma America, and we'll get back to the customer as soon as possible and answer their request.
All right. Andy, how about you? Somebody wants to know more about how they can utilize AI for their processes.
Yeah.
How do they find you?
So there's our website for sure, Praemo, Praemo.com. We also have a company LinkedIn page, a Twitter account. I have my own personal stuff out there as well, that people can find if they looking through the platform or looking through those social media platforms. I think those are the better ones.
All right. Guys, I appreciate your time today. Everybody out there listening, we appreciate you taking the time to listen to us. And if you got any thoughts or questions, please reach out to us. You can find us on the Okuma website. And I'm on LinkedIn and all the famous social media sites as well. So until next time, thanks again.